Hello, I'm Robert, and this time we're going to debunk the Arctic News blog. So if you search for Arctic News, and then you go down, you get this right to the top of Google search results. And this is just mistaken and fake. Basically, that's fake news. And Google doesn't even have any warning, nothing to say that it is. You can understand why lots of people link to it, because it looks very respectable. Looks nice, professionally done design, and then you look down, and then yes, you go to the About page, go to the Arctic News About, and it says a number of contributors have kindly provided content over the years. Then you go down and you look further background on contributors: emeritus professor, emeritus professor, advocacy consultant, founder of the climate, vice president, risk analysis. All these they look very impressive, don't they? Until you realise that he's just crediting everyone in an embedded YouTube video. So this video I'm making now, then it has the YouTube embedding license. Anyone can embed it in their blog. They don't need to ask me. Anybody anywhere can embed it, unless you explicitly, that's the default with YouTube, unless you explicitly disallow it. So this chap doesn't have a clue that he's interviewed by someone. He just doesn't have a clue that he's been embedded in his blog. Or if he did, and if he sent them chap an email, he probably wouldn't reply. So it means absolutely nothing that these people are embedded in his blog. So I hope that helps you to understand. So now look at what he does. He does the most absurd things. Not just schoolboy errors. I think he can't possibly believe what he actually says. So I've no idea what his cheese is, why he does this. But I mean, look at this. In this particular case, he says use fancy words which, if you've forgotten your high school maths, may seem impressive. So he says he's using a polynomial to extrapolate. You think, oh, that sounds fancy. That must be what people use. Mathematicians presumably use polynomials to extrapolate. Yeah, that makes sense. But a polynomial is an example of a polynomial is a quadratic. In fact, in this case, it's actually using a quadratic. So if you remember from if you do remember anything from your school days about, you may remember quadratics, and they go off to infinity in both directions. Surely you remember the curve of the quadratic, it looks like that. So, naturally enough, off it goes to infinity that way. But what he doesn't say, but he must know, is that if you go back that way, it goes off to infinity. In fact, that's his same curve, and I've just extrapolated a little bit further, and then I've gone back in the past. By 2003, it's the same temperatures he thinks going down. By 2028, the year 2000 will be about the same. And go back to 1900 or 1800, it's going to be a far higher temperature than the world has ever seen in its entire past history. So he must know that that's not a valid thing to do. And so if you go and look at other ones, here's another one of these. How long do we have? And here he says he's using QUADRATIC. And then then he's got this curve, then he fits this utter gobbledygook, just makes up things and adds them all together. And it says they're getting larger and larger and larger, and says, like this bit and this bit. These are actually real things, but not the temperatures he's added to them. He's just making up temperatures. And this is another one of his curves. And I tried just to show you a bit more about how these things work and why you don't use polynomials to extrapolate. That puts a straight line through it. This is my quadratic. I didn't do anything. I just went to a page which lets you extrapolate, interpolate polynomials. And I put in the data points. And my quadratic ended up being upside down, and my cubic ended up being like that. And then I thought I'd just continue the cubic, and I get this extrapolation. These are months, and these again months. So I figured out that within a quarter of a century, then You've got to watch out, it's going to get so cold within a quarter of a century, even liquid helium will liquefy. A joke, not. Polynomials are utterly useless for extrapolating beyond the data points you have already. And using a higher polynomial doesn't help at all. This is a degree 16 polynomial to those points. It just gets more and more wiggly. You can use polynomials for smoothing. And this is NASA. They're using polynomial smoothing. But they wouldn't use it to extrapolate beyond the last point. And this is the same data as for his quartic thing. You can see it's just a straight line if you do normal smoothing. It stayed, but this is due to the 19th century, early 20th century, and it starts increasing, and pretty much straight line. Increase in temperature, it's not increasing rapidly like he's got it. Then he just makes up his picture with fancy diagrams and lots of arrows and temperatures, just all made up. And then there's also the strange thing that all these people say. So there's him, and then there's Jem Bendell, who does his DP adaptation. He does the same thing. And then there's Rupert Reed, who's a philosopher, a colleague of Jem Bendell. They all say the same thing. They all say the world's going to rapidly get very hot, and they're based on nonsense like this. And another one, a chap called Bosdell, who does some other nonsense. That's the chap that Jem Bendell quotes. And then they say that an Extinction Rebellion. I've actually seen one of these Arctic News graphs in Extinction Rebellion talk, that one of them gave in a video of it online. And now this is what would happen if it really did get this is actual science now, not junk science. And so if we had carbon dioxide constantly, like we're doing now, we didn't reduce the emissions, and we are already pledged to reduce emissions. UK is pledged to reduce to zero by 2050. Several countries that are already pledged have already got decreasing. We've got quite rapidly decreasing emissions in the UK. US has slowly decreasing emissions. Only China is increasing emissions, but and India, but they're going to. So they're going to. China should peak by 2020, and sometime in 2020s, hopefully very early on. Anyway, if we were to keep going with constant emissions like we've got now, all the way through to 2100, and then we could get to 4 degrees C or a bit higher. And at that point, then those very red, the dark red areas there, and around the Persian Gulf, then they get hot enough so that if it's also very moist, which it would be if you're working in a paddy field, for instance, then you can no longer work out of doors for more than 6 hours. You simply can't survive, even if you're young and fit and healthy. Which means that they would have to stop working in the paddy fields. This is not all year round. We still have winter, we still have cooler seasons. This is quite a bit, fair bit north. It could be good. They have cooler seasons, and you still have the moist and dry seasons and all that. You'd have, and this would only be the hottest days in the hottest heat waves in the hottest part of the year. For a few days a year, then they wouldn't be able to work in the paddy fields. And so the IPCC, when they say in their report that you just can't, this is based on human decisions, you can't say when and how much migration is going to happen. Because people the Chinese rice farmers, rice is very productive, the rice would still grow fine in those temperatures. Then they might well decide, well, we can withstand staying indoors in these very hot conditions, considering we're getting such nice crops of rice. And they're actually adapting rice and developing varieties that work better at warmer temperatures. So they might say, oh well, we're going to stay here, and then they'd just stay indoors during the very hot weather, and they'd keep cool and dry as possible indoors, and they'd have air conditioning for comfort. Even if it failed, they'd be okay. as long as they're indoors and away from the paddy fields. So it's impossible to actually know what's going to happen, because we don't know how much people are going to want to stay where they are and how much they're going to want to move because they find it uncomfortable, or because there are too many stressors, or because they haven't got the money to pay for what's needed to adapt. So it's impossible to tell. And we certainly can stay where we are. Everyone everywhere in the world could stay where they are if they're having rather uncomfortable heat waves, but they're okay if you take the right precautions. All the way through to 2100, even with business as usual. But we might have large migrations even by 2050, and they think that there might well be quite a few migrate at 2 degrees C, less at 1.5 degrees C. But they can't say for sure, because it depends how well they adapt and how much people want to stay where they are. But if they did move, for instance India, they'd likely move to another part of India, China to another part of China. The Himalayas, there's some very cold areas there. But they just move to one of these slightly warmer places if they did migrate. So that's the reality. And it's hard to imagine how they can even imagine how they could be thinking in terms of human extinction. If you imagine much hotter than that 4.9 degrees centigrade, and if we were to go all the way through to 2200 or something, just producing carbon dioxide, just pumping it out and out, pumping it out. And so this is where coconuts are now. And that's coconut in India. Now, if there is actually someone who has grown a coconut palm in Italy, just an experiment, it's not easy to do. But if it were rather warmer, then this could be a familiar sight in the Mediterranean. We could just have coconuts there. But how is a world with coconuts in the Mediterranean too hot for humans? It doesn't make sense. It really doesn't make sense. Now if I go to this debunk, and I've got the other thing here which will help you see that. How can they go extinct in this world? So, and this is what the world would be like as it is now. Ice takes an awful long time to melt. And the ice in Greenland, if with this scenario of just burning carbon dioxide all the way through to 2200, producing carbon dioxide like we are now, business as usual, through to 2200, then that's what it's like in 2100. You can hardly tell the difference between that and the very low emissions where we hope to reach 1.5 C. And then this is the worst case, is by year 3000, 2000 years from now, that it could be that with business as usual, the 2200 thing, that all the ice eventually melts in Greenland, or there could be some ice left. And it's more likely there's some ice left with business as usual. So how do humans, so if people come into your school or talk to you on television and say humans risk extinction, just flash on that in your memory. How do humans go extinct in this world? Ask them for a site. They won't find one unless it's something like this Sam Karana chap, or the Jem Bendell, or the Wasdell chap, who is just as bonkers as this. And then the more about this absurd blog, right? So I was going to talk. I could go a little bit. I go further on in this page about how it's impossible, even if we burnt all the carbon dioxide like we're talking about there. Then it used to be this chap called James Hampson. I'll just very quickly go through that. He used to think that James Hampson in 2008, and this book that's still on sale and it's not corrected, but it's not true. He thought that that we could get to a Venus effect if we were to burn all the fossil fuels, including tar sands and tar shale. But then this was soon disproved, and this is 2000. He was never published. So he's a climate scientist, but sometimes climate scientists are kind of alter ego, as it were, when they write their popular books, and maybe they're a bit activist, and they want to get people to act. They say things that they would never put in a paper. This just worked out on a sheet, maybe from the back of an envelope, probably maybe on an A4 sheet of paper. and he figured this out, and he was just wrong. And he couldn't have got that through, he couldn't have got that published in Nature, what he wrote in his book. Anyway, people then started doing the research and they published it, and they found that it can't happen. And the latest calculation works out that the inner edge is 0.95 AUs. That means, so you need to understand, our Sun is it's a main sequence star. The stars, when they're very young, then they go through lots of rapid changes. When they're very old, like when our Sun becomes very giant, it goes through quite rapid changes. But at the moment, it is just one very, very slow burning. It's all hydrogen. It can only burn into helium. The temperature is very controlled and very steady at the temperature of the Sun, and which comes from its actual size and the amount of pressure from it, of the gravity, and from the temperature and the pressure and the type of star it is, the total mass, and the amount of hydrogen and the amount of helium in the middle, then it can just very, very, very slowly increase its temperature, and it can't do sudden changes. It can't explode. It's the wrong kind of star to explode anyway. It can't do sudden changes. The idea of a super flare, which some Sun-like stars can do, but mainly when they're very young and unstable. Our Sun is its magnetic field isn't strong enough. It doesn't rotate fast enough. It doesn't rotate. It rotates more slowly at the poles, and it should rotate more fast at the poles. It can't do a super flare either. So our Sun is just not the right kind of Sun to do anything drastic to Earth. It's just going to very, very, very slowly get slightly warmer, which is just as well. It's when our atmosphere started producing oxygen, that cooled the Earth down at just the right time when it was gradually getting too warm. Because an atmosphere with oxygen in it is much cooler than an atmosphere with lots of carbon dioxide, which is what it was before. So, and that may have been just a coincidence. Maybe our Earth was lucky at that point. It's hard to see why life would produce oxygen at just the right point in order to cool it down by some kind of feedback effect. Anyway, for whatever reason, the oxygen has cooled the planet down, and we can't produce enough carbon dioxide. It is there in all the limestone and chalk and the various carbonate rocks, but you wouldn't burn you wouldn't burn the coal and the oil and the gas. That's not nearly enough. You would have to find a way of digging up loads and loads of limestone cliffs and digging down deposits deep, deep, deep and converting it all to carbon dioxide, and that's not going to happen. That's why we're safe. Yes, and so the main thing preventing a runaway greenhouse, and Venus, even Venus, it would be quite hard, being much closer to the Sun, still quite hard for it to become a greenhouse, and it may have happened because of it didn't have continental drift, and without continental drift, then something happens that can bring all that carbon dioxide to the surface. But with that continental drift, that thing can't happen, and it's a massive huge super plume that covers the entire planet, and that could have been how Venus managed to get all its limestone and stuff to get it turned into carbon dioxide. But Earth, because of its continental drift and the continually moving continents, then that helps keep, that works as kind of radiator that keeps the interior a little bit cooler just below the surface, and that stops it getting to the situation where the limestone and the chalk would eventually turn into carbon dioxide, and so that helps keeps it cool. If you want a kind of longer technical detail, so anyway, I could go into more detail about that. But so we're okay. We're not going to turn into anything like Venus. And then don't worry about Stephen Hawking. He keeps making. He was very respectable in general relativity and quantum mechanics, but he says absurd things outside of that, especially towards the end of his life. And I mean, for instance, he didn't seem to know that our population was going to level off, and he gave a talk in which he calculated how hot the Earth is going to get, because it would eventually be human beings crowded together, so as many human beings as you could fit on the surface of Earth, and then how hot it would get at that temperature. And he gave a long talk about that, which was just, many of the papers just published it as is because he was so famous. He was so famous he could say almost anything. and people would publish it without any criticism. I did the criticism, but very few people did of that talk. So so don't worry about what he says about this. And so it's true. We could do this if we had 3% water that is today and weren't enough to have several thousand parts per million of carbon dioxide. That's not possible with us. And possible millions, hundreds of millions. And it's a valid projection in a way, but not for us, but for distant future creatures in a much hotter world. And there'd be many ways to deal with this. Shade our planet with giant thin film shades in orbit, or they can move it. Or maybe they're living in space habitats throughout the solar system. And lots of places you could live in the solar system that are nothing like as good as Earth. But for instance, in caves on the moon, the huge caves on the moon that you could make habitable, filled with atmosphere, and they're big enough so you could put the city of Philadelphia in one of those. And although it only begins to make sense once you've got very large numbers, like hundreds of thousands of people there, then it does have some advantages that there's no earthquakes and no volcanoes and no hurricanes, and very stable. And if you can manage with the low gravity, then you could just fill it with the atmosphere, and then very self-contained, self-sustaining system. And you have these caves that could be as big, could be up to 5 kilometers diameter. We don't know for sure. They might be only a few tens of meters in diameter. They seem to be about 100 kilometers long. There's lots of space to live on the moon, and there's lots of other places in the solar system. But so who knows? Maybe in the future, then the people living throughout the whole solar system. But the Earth itself is going to remain habitable all the way through for hundreds of millions of years into the future, and we're actually working together very well too. You don't I'm really, if you come, people think, oh, nobody's doing anything, but if you've been following it since climate change began, like I have, since people first had the idea of climate change, of global warming, then it's really remarkable in just the last 5 years how much has been happening. Nothing and nothing for decades and decades, and then suddenly in 5 years there's so much going on, so many positive things going on. And okay, we haven't quite done it yet, but I think in another 5 years, another 10 years, then we can not just manage to stay within. We've already knocked 4.9 down to 2.9, I mean 1 or 2 degrees, depending how you do your extrapolation. And we've actually knocked off with the pledges in 2015, and we can certainly go the rest of the way. It's harder to go the remaining 1.5 degrees, but we can do it. And so anyway, there's no risk by that tiny sea creature. This tiny creature, this about 540 million years ago this thing lived, and it's about 1 millimeter across. Very strange creature. Then it may have been one of our distant ancestors, or a distant sort of like cousins that many times removed. And it could evolve, something like this could evolve all the way to humans before the Earth could become a second Venus. So over that time scale, so you don't need to worry about that. So now, I'm going to go back to, so that was just sort of looking forward ahead. Now I'm just going to go back to his thing here, all this stuff he says there, all the gobbledygook, and that's based on. So I've got a debunk of that there. So the two things it's based on. One is that he talks a lot about the Arctic ice. Same with the Jem Bendell, he talks about Arctic ice, albedo effect. And they bring up this word, it sounds like a techie word. Oh, albedo effect, that sounds very scientific and sensible. They must know what they're talking about if they can use big words like albedo effect. But no, they don't have a clue, and they don't understand the words they're using basically. So the albedo effect is it's just that the Arctic is getting less reflective, but other parts of the world are getting more reflective. And that's the thing that they forget. And they look at it and they say, look, the Arctic is getting much warmer more quickly. And so that must mean there's something very special going on in the Arctic. Ah, and the Arctic ice is melting. Ah, that must be why the Arctic is getting so warm. But if you look at it, the Northern Europe, I mean, we're getting warmer, and we've got no ice that's melting. It's not an albedo effect that's warming up Europe. And the reason we warm twice as much as in the tropical regions is because, and this would happen even if it was a pure water planet, an aqua planet, completely covered in water, it would still happen that it would warm up more at the poles than it does in the tropics. And the reason is because you get more convection if it's warmer, and so you get more, the heat gets distributed more towards the poles, and that's the real reason why the Arctic is warming up so much. There is an albedo effect, but it's a minor effect on top of that. And I mean, that's just obvious. Just remember the Northern Europe getting warmer. It's obviously not right that the Arctic is getting warmer because of the albedo effect. And then why then isn't Greenland getting warmer? It's because you've got a big, very freezing, very, very cold continent there. And you can work out the scientific reasons why a very, very cold continent counteracts the greenhouse effect in the southern, called anti-greenhouse effect. Especially in the Arctic winter, and kind of cools down even more because of the carbon dioxide. It's quite a surprising thing. If you don't, you better go into that another time. The papers on that. So if you look at what's the change in the reflectivity, then it's got less. That's all albedo means, like the kind of reflectivity. Like white is more reflective than dark, and so it's got less reflective in the polar regions, but it's got more reflective there. You can see the blue bits are more reflective, the green is more reflective. And if you average it, if you do the maths and average it out, then the paper I got this from, then they work out that it's actually got slightly more reflective in the northern hemisphere, even including the Arctic, and with that Antarctic thing, it's got significantly more reflective in the southern hemisphere. So we don't need to worry about the albedo effect. It's actually helping us rather than being a tipping point. And the IPCC, they found that out in that it's actually like that. And I want to just bring up something, a misunderstanding that people have about how science works. So Rupert Reed, for instance, he's a philosopher, and in philosophy, then you get people with some very way out idea, and generally you get some kind of things like some kinds of philosophy just they're considered almost to be wrong. Like some of the early 20th century philosophy is thought to be kind of basically wrong, but you can, if you work really, really hard, you can make almost any kind of philosophical idea work. You get these people with very strange philosophical ideas, but you can't actually say they're absolutely wrong, and there's always a range of ideas in philosophy, and people with very out of the very end of the bell curve kind of ideas in philosophy, and you can't actually say they're wrong. But it's different in science. So look, for instance, the melting point of iron, 1,538 degrees centigrade. You don't have someone saying, oh, the melting point of iron is 10,000 degrees C, that's my philosophical theory. And someone else says, no, my philosophical theory is the melting point of iron is 5 degrees C, and if you hold it in your hands, you will actually make it melt, like gallium. And that doesn't work in science because it's evidence-based. And so it's the same with the IPCC. The IPCC is aiming for consensus. And all these people, they sort of say, oh, you shouldn't listen to the IPCC. Everybody knows that they're just aiming for a consensus. And scientists do that. They try and get a consensus. And we should ignore them because you shouldn't do that. Because you should listen to everyone. And that sort of, like in politics, it makes sense if you're used to politics and philosophy. But that does not make sense in science. You don't listen to everyone. If someone says that iron melts at 5 degrees centigrade, you don't listen to them because they're just wrong. And so it's the same with the IPCC. there's certain areas of climate science, like for instance, like what I was just talking about, and that's why I thought this is a good point to bring this up. Then we know that the albedo effect is not going to be a tipping point, and the best science is saying the best we know is that actually it's just not even any kind of bifurcation. That just if you warm it up and then you cool down, it cools down the same way. You don't have to cool down more in order to get back again. You just cool it down and just reverse the way that you went up. So this, just like the melting point of iron, then we're converging towards a consensus here about the albedo effect. We're still got some differences, and so now if you go and look at these other things, like look at, for instance, it's very difficult to know what's going to happen in the Arctic with the methane and the carbon dioxide. You can see it's all over the place, and we still think, some people still think, it's still possible, especially with low emissions, but even with high emissions. And these are the dates on which the models were published. That's all that is. If you can see even the most recent models, then it's a sink, and that's a source. It could be that the entire Arctic region is a sink for carbon, for everything, carbon dioxide and methane. Could be a sink. The reason is because as it warms up, you're going to get lots and lots of vegetation growing, and you're going to get peat bogs, which continue taking in carbon dioxide, and grass growing, and grass takes in carbon dioxide. And then the methane in the sea, that actually fertilizes some microbes and causes them to take in carbon dioxide as well. So lots of sinks there, as well as the sources, and the newspapers, the reporters tend to only report these ones below the line, and they don't report the ones that go above the line. They report the sources, they don't report the sinks. So if a paper says there's going to be a big sink in the Arctic, then that's not going to hit the news. Whereas this one down here probably will. That's just the way of it. And this is from the IPCC, and they do a review of all the literature, and they look at all the well-founded, good evidence-based science, and these are the reports that they have found. That's 2019 report. And then so these people go on and on about the Clathrate gun hypothesis, and that is basically that's gone the way of the dodo, as it were. It used to be a somewhat respectable idea in 2003, and then all the way through to about 2015. Then there was still this model suggesting 6 degrees rise within 80 years. Not 5 degrees, not 6 degrees in 5 years, 80 years. And then, but then there are all these things, the methane don't get to the surface, and the clathrates only decompose to 1.6 meters depth, not as deep as they'd expected. And then a cage group, this group is specifically looking at methane clathrates. They found this has been escaping at the same rate for millions of years, because these people found the methane escaping, and they thought, oh, it's just started escaping. Maybe it's going to get worse and worse. But no, it's been doing that for millions of years. And then we come to the IPCC report, and now it's just disappeared. It's no longer there. So I have to drink of water. Dry throat. So, and this is one of the, this is a study, a scenario that they link to at the end, in the last paragraph, say, as total carbon emissions is high confidence, a mitigation of anthropogenic methane sources could help to dampen the impact of increased methane emissions from the Arctic and boreal regions. So this is this graph they're talking about. The IPCC report refers to this paper. So human emissions have increased in the methane like that. And then if we just continue as we are, they're going to increase like this. Now this is human methane emissions, only a few percent of the total human emissions. So this is just a small amount of the total. And if we do continue with human emissions, and we can counteract them by other things like, and this is already in the atmosphere, and methane disappears very quickly from the atmosphere. It's like a constant thing in the atmosphere at the present. And if we can reduce it, then we're reducing the methane effect in the atmosphere. If it just stays steady, then it's just as it is now. and so the world wouldn't get any warmer because methane just stays there in the atmosphere. Methane doesn't build up in the way that carbon dioxide does. So this is the actual amount of methane in the atmosphere, it's not the yearly emissions. So as you see, it's levelled off. On methane, methane we produce here now, within 15 years half is gone, within 30 years a quarter is gone, within 45 years we're down to an eighth. And so you have to keep on producing it to have its effect. So we already have this methane effect. And if we have deep emissions, we can reduce it, which will help to offset. Actually, reducing methane emissions help to offset some of the other stuff. Reducing methane emissions together with reforestation, diversity certification, and so on. These are all ways we can offset our increase in emissions from now. Now, so that's where we're headed, which would actually make things worse, actually increase the methane emissions with current policies. This is if we have deep reductions in methane, which are practical, and we can actually use that to offset. Now, if we have the extreme pessimistic scenario of natural emissions release, this is the worst case, tundra and lakes increase markedly, extreme increase in the ocean emissions. That's from the Clathrates. Then that gets us to there. And that's not likely if we stay on our low emission scenario that we will get there, but I just added it anyway. Because these are separate scenarios, they don't know quite which of the emissions corresponds to which of the methane things. So with that very pessimistic, extreme pessimistic, that's the worst case for the methane Clathrates and the methane on the land and everything. That's slightly increase of methane over the current levels. It's a slight increase instead of being an offset like it should be. But that's not likely. It's more likely one of these, or even right down there, or even negative. Especially on low emissions, it can easily be a net sink. It's certainly possible, it's down there. It all just depends on what the microbes do because in the Arctic there's a lot of old organics that's just frozen grass and frozen little animals and things from way back when it froze. And as the permafrost very slowly thaws, it takes a long time for it to thaw. They talk about rapid thaw. When you hear about rapid thaw, it's rapid thaw of little lakes, little pockets. The whole thing can't thaw because it's just too much thermal capacity. It's just not possible for all the permafrost to thaw rapidly. And so that unfolds over centuries. And as it does that, then you've got lots of nice organics to make nice rich soil. And that is, certainly some of it is going to be making nice rich soil. And really, it's very hard to tell how much of it is just going to be enriching the soil with organics and how much is actually going to turn into methane. And if it does turn into methane, which would be in anoxic conditions if it's very damp, then on its way to the surface, then microbes can eat that as well. And most of it is probably beaten up on the way to the surface. And then there's the carbon dioxide. So that's why it's so difficult to tell what's going to happen. It's very different from the Arctic ice thing, where it's just basic physics and understanding how the ice works. But in this case, it's a case of trying to guess what's going to happen with the microbes and the plants, and it will depend on how many fires there are, and whether people might do things like you could block the waterways and turn it into a peat bog, or you could let fires burn or stop the fires burning. And anyway, so they don't know what's going to. They don't know. It's extremely hard to predict, and we keep on getting things going both ways. At the moment, it looks like it's likely to be a source, possibly, but we're still getting the sinks turning up, even on high emissions, with some of the papers. So somewhat more sources, bigger source, but we still get the sinks papers being published. And anyway, it's just a small amount. So that's the methane, and I did the Arctic ice, so I've done that. Yeah, that's other stuff. So I think I've done most of this. The 8 degrees C thing from clouds, I've got a special debunk about that as well. It's something like 1,400 parts per million parts per billion that we would have to get. That's beyond, and that's just at the lowest end of the range. This is at a certain point, this is a genuine tipping point, then very low clouds over the oceans, and they dissolve away at a certain temperature point. And that helps to explain some of the warmer conditions that have been in the past. We're still just talking about coconuts in the Med temperatures there, but that may help to explain some of the higher temperatures in the past. But this is only possible at much higher emissions than we can do by 2100. That would be the case if we were doing this thing with just carbon dioxide emissions on, like James Hansen thing, continue all the way through 2200, then we could trigger that. He's just made it up, he's just popped it into, and he's saying, well, you see, he's managed to make up, he's saying that we've had, that we're already at 2 degrees C, which is something further back, and he's managed to make up all 8 degrees of increase from all these C4 methane and the ice and the black carbon and thing. He just made up temperatures, made up numbers from those. What is that green thing? Falling wave surface cooling. I don't know what that means. Falling wave surface cooling, that's probably the albedo effect. So he said that he's got 1.9 of albedo effect. But he's saying that the Arctic, but remember it's going the other way, it's actually going to be cooling. So anyway, just ignore him. He's a nutty. But I mean, there's no way. There's absolutely no way that he can actually believe this. I don't see how it's possible, even if he's just a schoolboy. You've no idea what age he is, unless he is. Someone claims he's one of these, that he is a particular person. I don't know how they can know for sure. And no idea what his motive is, just to be kind of famous, or is it that he wants to be? Some people are saying that he's trying to discredit the climate change by being this extravagant thing. So I don't know. I have no idea. I don't know how you can tell these things until he says, and he won't let himself be interviewed. Nobody's heard his voice as far as I know. And so that's so there's just no way he can not know that his curve goes up to infinity that way. So anyway, I hope this is enough. I hope this can get to some of the people who've been believing this absolutely absurd Arctic blog thing. Utterly silly. And I hope also, sadly, the Extinction Rebellion people, some of them, I think, if anyone from the Extinction Rebellion is watching this, then some of them have believed these curve graphs. I saw in one of the talks. And then there's the Jem Bendell and Wasdell, whereas this long labyrinthine paper was basically saying the same sort of stuff as this, but I don't know, they never passed peer review. He gave it as a talk to some businessmen, and he himself is a systems analyst. Never got any climate scientists to comment on it. So these are the people that you're getting scared by. Don't listen to them. They're nuts. They're not. Remember, this is what science is like. These numbers. If Google's got it right, lead 327.5. Someone can't just suddenly say, oh, lead actually melts at minus 10 degrees C or melts at 10,000 degrees centigrade. That's just not how science works.